Hi, and welcome to this roundtable dedicated to sustainable aviation. My name is Xavier Titelman. I'm a consultant in aviation for Starburst. Starburst is a lot of things. It's an accelerator where a lot of startups come here to go further in their business development. We also are a consulting company with a great team all around the world, in Asia, in Tel Aviv, in the US, in Europe also, and France, of course, as you can see with my very bad accent. Here today, we're very happy to welcome three amazing guests coming from the whole industry. They represent the whole aviation sector with Valérie GUENON. Hi.
Hi, Xavier.
Emmanuel CACHIA. Hi. And Florence Robin.
Hi.
Hi. Valérie, can you explain who you are?
Yes, so I work for the Safran group, Safran, aircraft engines and equipment. I am in charge at Safran Aircraft Engines Company. I am in charge of the environment policy for products.
Emmanuel.
Hi, so I'm Emmanuel. I work for Transavia, the low cost of Air France, and I'm pilot and flight operation director.
On which plane?
Yes, on Boeing 737.
How many planes do you have in Transavia?
Today, for this summer, we have 48 airplanes.
And how many pilots?
It depends, every day change because we have a lot of training, but this summer will be around 500 pilots.
Yes. In Florence?
Hi, I'm the CEO and founders of Limatech. Limatech, we develop lithium batteries for aviation. We are from a CA French lab, and we are 15 people between Grenoble and Toulouse.
Okay. Valérie, I think that you're also part of the ATAG. Can you say a word about it?
Yes, so yeah, I am a member of the board of ATAG. So ATAG stands Air Transport Action Group. Air Transport Action Group. So it's a group of aviation international industries with airlines, airports, air traffic control, and manufacturers.
Great. And can you talk about the aviation commitment toward sustainability?
Okay. So, well, aviation commitments, there are several of them. It's interesting to, so I can mention the international aviation commitments first, and then I can also mention the European commitments. So back in 2008, ATAG, so these aviation industries, international aviation industries through ATAG, made a commitment. So if you remember, we were still far from the Paris Agreement. There was even an economic, but that's not the subject. And so they realized that we were enjoying quite a very successful traffic growth. In the last 20 years, it was about 5% per year. And we realized that if we were going to continue with this traffic growth without doing anything, if we did nothing for CO2, then our carbon footprint would become unacceptable. So these industries made a commitment to reduce their global emissions respect to 2005 and to divide by 2 overall global carbon emissions due to civil aviation. So that was a very historic
Despite the growth.
Despite the growth, yes. Of course, our objective was to enable the growth, but to make it sustainable. We want people to travel. We want to have more aircraft in the sky, but it has to be sustainable. So that was the commitment. And then, but these were only the private sector commitments, so companies, industries. And then you have the ICAO, the International Civil Aviation Organization, that is a group of member states, 193 member states. And this inspired ICAO to also make a commitment, and at that time the commitment was a little bit less, it's more difficult to agree between 193 states, of course, than between 20 companies. But they did make a commitment, and in particular, they created CACHIA. So CACHIA stands for Carbon Offset and Reduction. setting scheme. And that was also quite historical because all these countries, ICAO is a United Nations organization, all these countries agreed to commit and so that all CO2 emissions that would be above the 2019-2020. So that's a commitment that is
quite unique.
It's quite
in
unique.
The whole industry, right?
It's quite unique because the airlines commit to pay to pay offsets for carbon emissions, basically. Make it some. So that was also quite impressive. And now ICAO is now currently working on a long-term goal for CO2 global reduction. It's taking 2 years. Well, it started last year and it will be delivered in 2022 at the next ICAO assembly. And all these member states will also agree on reducing the CO2 emissions for 2050, or it's still under progress. It's being under discussion. So very difficult discussions because we are many countries with many different situation, economic situations, and so on. So that's for. If you leave me some time, I don't want to take all the time, but if you really give.
As long as you need more.
So then, if we can word about Europe. First of all, Europe, back in 2001, Europe had set some objectives. They are known as the ACARI objectives. And at the time, it was objectives for reducing CO2, NOx, noise. So not only climate aspects.
The global environment.
The total environment impact. And those objectives were, based on technology. So they were per passenger kilometer. It was not the same metric, but already at the time, they had identified the environment as a challenge that aviation had to address for the next 20 years and next 50 years. Now, in Europe, what's going on now? If you are European citizens, you may remember that you voted in 2019. So you voted for the new European Parliament. And so this parliament was renewed and then it created a new commission. And this new commission has set up its policy vision, which is based, among others, on the Green Deal. So if you heard about the Green Deal, this is something that, as European citizens, is going to change our lives. Back in March, the European Union, so Council, Parliament, Commission, agreed on the Green Deal objective, climate objective, which is carbon neutrality in 2050. So in the European Union, we are aiming at carbon neutrality in 2050, and this will go through an intermediate step of minus 55% reduction, so 55% reduction in 2030, so 2030, so 9 years from now, so tomorrow. So minus 55% with respect to the 1990 levels. So that is absolutely historical. It has not made the big headlines, I have to say, when I read the news, but okay. So, and the European aviation is also getting prepared for that. And they have we have, because we contributed as a Safran, a roadmap, which is called Destination 2050, which is available and which describes how we are going to reach carbon neutrality also as the European aviation. Voila.
Great. And we see that, okay, you have lots of things to do, but a lot of things has been done already. We see that about 50% reduction in fuel efficiency for the passenger about the last 30 years. So, Emmanuel, as a pilot in Transavia is one of the most efficient airlines in the world. You were 5th on the classement, je sais pas comment on dit. Merci. How did you manage to be such efficient?
Thank you, Xavier. Yes, it's true that we are a bit lucky in Transavia because from the beginning, from since the first flight of Transavia in May 2007, the fuel conservation, fuel efficiency is in our NDA. So it is a culture in our airline. So we start with a lot of best practice at the beginning, and we work year after year to be better. And today, it is natural when we have a project to think how we can reduce our fuel consumption, and how we can reduce our carbon footprint. Today, all the staff are very involved, particularly the pilots. As you know, we have a lot of best practice that we can apply every day when we fly. And today, so as soon as the first hour in our airline, during the welcome day, the chief pilot or I present our fuel policy and the interest of it. There is economical interest, it's true, but today we are sure that the ecological interest is the most important. As Valérie has present at the beginning, we have a lot of goals today, and we know that it is mandatory for our industry, for the airs. So we have the challenge to succeed. And now, so we work with all the team to reduce our fuel consumption. Concerning the eco-flying, so today the pilots are so involved by a lot of best practice. And the first one is the fuel that we decide to have in our tank just before the flight. So today, the policy of Transavia is to have the minimum fuel. We can say that because we know that our flight plan, operational flight plan, are very efficient, are reliable. The pilots are confident in that, and so we can manage a minimum fuel according to the weather, according to all the safety that we can.
You still have a 30 minutes reserve, right?
The regulation, but in the past, sometimes because we know the airports, we wanted to have more fuel, but in fact, we have discovered that it's not necessary. So today, all the pilots, their policy is to have the minimum fuel when it's possible, for sure. The second one is the reduced acceleration altitude. So when it's possible, because some airport is not possible, but today we can have a reduced acceleration altitude at 1,000 or 1,500 feet. And with this best practice today on our Boeing 737, we can reduce the consumption of 25 kilograms per flight. So it seems to be very low, 25 kilograms, but like all the best practice that I will present today, the result is done by the number of flights. That is very important. So we work on the taxi out with one engine only, on the continuous descent approach, and we have a global vision of the fuel reduction, and so we work on the weight reduction of the aircraft too. So today, when we expect to buy a new trolley or new seats, we are looking for the lighter one. And today, also a few weeks ago, we decided to change the carpet of the aircraft. And with this changement, we can reduce the consumption per flight of about 9 kilograms. But in a full year like 2019, this reduction for Transavia is around 400 tons of fuel. So only with the new carpet. We wash our engine. So we follow a lot of the recommendations that we can read in ICAO or Boeing. So wash the engine, use of GPU, so on the ground power unit instead of auxiliary power unit in the aircraft. And we work with a lot of startups to develop new best practice if we can. So we have developed with a safety line. So we are a partner, and so we are the launch airline of the tool OpticLime. So it's a tool which use big data, and before each flight, this tool optimize the climb with the speeds, according to the weather of the day, the wind, the weight of the aircraft. And with this tool on Boeing 737, we can reduce our consumption around 80 kilograms per flight. So it's quite a lot, because when we have all the other best practice, like taxi out on one engine, like reduction altitude, what I have presented, optic climb only is around 80 kilograms, and the other ones, all the other ones, is today in Transavia 45 kilograms. For us, what was important from the beginning is to have a vision of the result of this policy. And so we met in 2011 Alexandre Ferré, the CEO of Open Airlines, and we discussed with him, and he understood that we have a need, how we can see the result of our policy, because in 2011 we are totally blind. We had a policy, the pilots applied this policy, but it was well applied. What are the results? We didn't know. So he has developed with his team a tool. It is SkyBreeze. And today, with this tool, the management could have a global vision of the fuel policy in the airline. And that is very important for us to involve the pilots, because we can see, okay, this one is well done, but this one, we have a lot of fuel saving that we can reach. So how we can reach this fuel saving? So we work on our communication, or sometimes we change our procedure to be better, and so to have better results. And the pilots have the same tool, but with the personal results. So management, we don't have personal result, it's totally confidential, but the pilots could have his personal result. It's a mean for us to involve the pilots in this goal and in this policy.
Congratulations. You mentioned Open Airlines and Safety Line. Just both of those startups have been accelerated by Starburst. So let's continue with them. Just a question about, I think that you're about the consumption per passenger is about 2 liters, 2.3 liters per passenger.
Yes,
like
with all this work, so with best practice of the pilots, the light trolley, carpet, everything. Today, the consumption, so the last full year in 2019, the consumption per passenger per kilometers,
100 kilometers.
per 100 kilometers, sorry, is 2.6 liters per passenger. Yes, so it's quite good. And today we are still working with startups or with other subcontractors to be better in this consumption. And since 2011, we have reduced this consumption and our carbon footprint by 14%. With all this eco-flying,
which is huge. In comparison to the French average, it's a 3.4 liter per passenger per 100 kilometers. So it's much better than the average.
Quite good. Thank you.
Keep going. Valérie, we've seen that there's a lot of things thanks to optimization of the operations. And on the technological point of view, what are the next steps?
Yes. If I may, because what Emmanuel said triggered an idea that I want to share. I mentioned the roadmaps and the objectives. And all these roadmaps and objectives, the ATAG roadmap, the Destination 2050, the ICAO thinking, they are slightly different, but they all rely on the same levers. And those levers, technology, flight operations that you mentioned, and there is also the load factor, I think that's quite important. ATM improvement, the use of new types of energy, so sustainable aviation fuels, and in the last, for what remains, and really those levers are really the same. There is a consensus on that. We need to do all these aspects. So yeah, for the technology, so of course we've been working on technology for the last 50 years. Ever since aircraft existed, we improved the technology and we improved the fuel consumption. So we work on the fuel consumption at first because it was an economic incentive for us, for the airlines, for our customers. And we also have very much improved our environment footprint through noise and polluting emissions because of the international regulations. We have to comply with the regulations. So how did we do that? So first of all, the weight. So you mentioned the weight of the carpet, which is extremely important, of course. So we've been working on the weight, and so the weight, reducing the weight is the first objectives. And in the last 30 years, the use of composite materials has been really has brought a revolution, actually. So we continue. It's not only working on materials in general, using materials that are lighter with the same mechanical properties. This is really something we continue. There is still room for improvement. And there is a new revolution that is coming after composites. It's the additive manufacturing that allows us to design parts that we could not design before. So we can design parts that will be more efficient, lighter. It's also a revolution in the production processes and everything, of course. So weight, the aircraft manufacturers, they work on the aerodynamics of the aircraft, of course. The improvement has been made also there. I have to speak about the engine technologies, of course, because the engine is the part of the aircraft that produces a lot of the noise. So engine technology is extremely important. We have made, well, the engine, there is an evolution of the engines, in particular the increase of what we call the bypass ratio, which makes bigger engines. And
you've just signed a new agreement.
Yes.
Which are the goals?
Yes, absolutely. Yeah. 10 days ago, CFM announced, so the mother companies of CFM, which are Safran Aircraft Engines and General Electric Aviation, GE Aviation, announced the next generation of engine, which is called RISE. It's the RISE project. So it will be a new engine architecture that will bring an additional 20% fuel reduction with respect to the LEAP engine, which is currently really the state of the art. And the LEAP engine itself demonstrates 15% fuel reduction with respect to the previous generation. So we are continuing. We know how to do it. It's becoming more and more challenging, more and more difficult from the technology point of view, but we know how to do it, and we're continuing. And the last, well, the last one is not technology, but technology is concerned by it. It's the use of new types of energies, of course, and sustainable aviation fuels, electricity, hydrogen.
And when we're looking at the full scope of CO2 emissions in the aviation sector, in the aviation industry, we're also thinking about the factories. Safran has a lot of factories. Do you improve them also?
Of course, yes. We have a big project called the low carbon project, which is addressing specifically the greenhouse gases emissions of our facilities, our factory, our industry. And so, yeah, we do have actions such as photovoltaic, production of electricity, eco-generation, wind turbines. And we are working now on using sustainable aviation fuel, so based on biofuel-based, for our test benches, for our engine test benches. We use 80,000 tons of 18 Yeah, sorry, no,
15.
18.
Okay.
No.
1,000 tons was a lot.
No, sorry. Okay, forget the number, but we use a lot of kerosene for our test benches, and so we aim at using 10% of sustainable aviation fuels at the end of this year, and to go up to 35% in 2025.
Great, thank you. Florence, we heard Valérie explaining all the future options. One of them is the electrification, and you produce amazing batteries. What are the targets for you?
Yes. Concerning electrification in aviation, we identified 3 steps. And step 1 is to replace old batteries with lighter and less polluting batteries. And at Limatech, we develop lithium batteries 3 times lighter and 2 times less maintenance, and with a 10 years lifespan. And the step 2 is hybridization engines. For the moment, hydrogen is the best way. And for the step 3, for full electric propulsions, we already work on high voltage batteries. And for all these 3 steps, they need batteries, and Limatech will be ready.
So you're telling that your batteries could be lighter. We didn't mention it in detail, but when we save 100 kilograms on an aircraft, we save about 3 kilograms of fuel per hour. And how many kilograms will you save, for example, on a Boeing 737 or A320?
For example, for an A320, we can save 120 kilo. And it's the benefits is really important for market players.
Okay, of course, because it will save hundreds of kilograms of fuel per year per plane.
Yes.
Of course, great. And is this next generation of battery less harmful for human or environment?
Yes, it's we replace lead or nickel cadmium technology in the batteries with lithium technology batteries, and lithium it's no toxic against lead or nickel cadmium.
We don't get cancer.
Yes.
Okay, to be clear. Okay, that's a main improvement for human life also, and for the whole value chain. Right?
Yes, and in 2020 we were selected by the European Council Innovation for the new Green Deal program, as Valérie said in the beginning.
Okay, that's great. So you're working already with some industrial big companies?
Yes, for example, Airbus.
Okay, that's a big one.
And I hope with Safran.
Okay, we'll sign a deal after the talk.
Okay.
Thanks. Emmanuel, do you see some other, for example, Valérie talked about the improvement of the ATC. In your point of view, first, what do you expect from the improvement of the ATC, and do you see any other lever?
Yes, we with every day with the flight, we can see that we have today an improvement possible. We can reach fuel reduction with new ATC procedures. That's for sure. We can see, for example, on our flight plane, the routes are not direct, so we have a lot of route that we have points, but this points is not a line, so it's not straight. The other point that we can on which we can have better result is with a continued descent approach. The results and when we can see every day is that it's very different in the country in Europa. So sometimes it's very easy to have a continued descent approach. Sometimes it's more difficult. It's true that when the airport is with a lot of traffic, it's more difficult to have something continuous.
So it was easier in the past few months?
Yes, for sure. Yes, for sure. And for example, because it is our experience, we have a lot of aircraft based in Paris, and it's true that when we arrive in Paris, the beginning of the descent is very early. If our flight plane, we have a descent about 80 nautical miles before the airport. When we arrive on big airport, it could be 200 nautical miles due to the procedure, the arrival that is mandatory for this airport. So we can have a lot of, we can have a lot of progress.
Because you try to glide?
It's like this, yes, we have a full idle. So the aircraft today are very well equipped, and with the automatism, we just have everything is in our computer on board, and the aircraft we have full idle on the engine, and so only with the energy we descend, and so the consumption during all the descent is very low, very low. It's I don't know exactly, but it's very low. It's quite zero, quite. And so when it is well done, and we can see with our tool, with Scaleway, that on a lot of airports is well done because the process could be like this. But today we have a lot of opportunity on other airports, and today it's not easy, but to be totally frank, the discussion is beginning on this subject.
Okay, let's go. We see that you have a lot of opportunities to save fuel. Is it just because of greed? We want to save money, or is there some just ecological perspective?
For sure, the money is a fact. But as I told you at the beginning, we know, and Valérie has very well explained what is our target and what is the vision of our industry. We know that we have to be better. We know that the growth, we need aircraft today, and we know that we have to be better to still have this industry in the future. So, for example, we are low cost, but we are an airline, and in the past, sometimes we ask our pilots to have economical fuel. It is a fuel that we know that it's necessary to tank because the fuel at the airport at arrival the price is very high. So we have fuel just to tank the fuel because the price is very high at
just to avoid to buy, for example, Ajaccio is quite expensive in regard of all the other airports around.
I don't know if Ajaccio is quite expensive, but it is an example, yes.
And so instead of buying it at Ajaccio, some airlines come to Ajaccio with the full tanks.
Yes,
so they don't buy it there.
To have to buy the less quantity at the airport where the fuel is very high. So it was a practice in the past, the tankering fuel, it was the name. And today we have totally forbidden. And today we don't have any tankering fuel in Transavia.
So you save fuel.
We save fuel, but we don't save money.
So, but still today, I think maybe you will correct me. Fuel tankering is still 900,000 tons of CO2 emitted every year in Europe. So I hope all the other airlines will follow your very good example.
Thank you.
You've talked about changing the carpets.
Yes.
Okay. Can you imagine having some new batteries in the next future?
Yes, for sure, because as I told you, we have a list of points that could reduce the fuel consumption, and the weight is very important. And so if tomorrow we have a new battery with a lot of reduction, so more than 100 kilograms per battery,
it's huge.
It's huge. So yes, why not?
And when will you be ready to go on the market?
Yes, we will sign the
agreement
just after the agreement.
It's a good day for you.
Safran. Okay, we'll be ready to sell in 2023.
Okay, so it's quite
fast. It's tomorrow.
Okay, tomorrow. Let's sign. That's the truth. You've been talking about the sustainable fuel. It has a cost. Yes, it's much more expensive than current kerosene. Do you have an idea of how much it will be?
Yeah, well, that's you are raising the main challenge for sustainable aviation fuels currently. Yes, the challenge is not so much technology challenge, but it's really the availability. Cost, no, 3 times more, 4 times more than kerosene. Kerosene is fantastic. Kerosene has all what we want. with kerosene. They were all designed for kerosene. Using sustainable aviation fuel is really a revolution and is really going to ask us a tremendous change. Yeah, the main challenge is the availability, and the cost goes together with the availability.
Just because, to be clear,
yeah,
SAF don't use palm oil. We don't use what is not sustainable. So it's only from garbage waste, from crops that were not used. So to be clear, there's no concurrence between SAF and food or the nature. It's really another way to produce, and that's why it's expensive also.
Absolutely, you're right. What SAF means, sustainable aviation fuels. And so sustainable means that there is no deforestation, no killing animals, no bringing people into poverty, or not competition with food. So absolutely, you're right. And there are criteria that are strictly defined, and they are approved by the ICAO to say if such type of production is sustainable. So yes, and that's of course one of the reasons why they are expensive. It's not the only reason, but it's also a fundamental criteria, and we will be absolutely adamant and will not comply with this aspect. Indeed.
And what is the reduction of the fuel emission, the CO2 emission on the global cycle?
Yeah. Yes, because the thing, yeah, on the full life cycle, you're right. So the question is, because if you burn SAF is a fuel, and so you burn it and you create CO2. You do it when you fly with the SAF. The question is, so you have to look at the overall cycle, life cycle, and the principle of the SAF is that you emit CO2 that has been absorbed before by the plant, or it burn, let's say, garbage, because there are SAF that can be used out of garbage. Then you burn for flying instead of burning for disposal of the garbage. So that you have to address the full life cycle of the product.
For example, the oil from the fast food.
Yes, that's an example. Yes, yes.
So instead of French fries, it's good for the environment. Okay.
Yeah, instead of being incinerated, yes, yes. Yeah, I don't know if that answered your question.
That's the question. Okay. And is it main issue for you? I mean, you made good example, for example, about fuel tankering. You don't practice fuel tankering, but if you buy SAF and that's your opponent don't use it, is it a big issue for you? And how can you reduce those differences?
Today, the SAF is a regulation. It will be a regulation in France on the 1st January 2022. We have to introduce 1% of SAF in our fuel. And we'll have the Europe regulation in the mid of July. So it is a regulation, as all the carrier will follow this regulation. The fact today, the problem for all the carriers, I think, in France and in Europe tomorrow is the supply chain and the production of this stuff. Today, Air France has done the first long-haul flight with SAF a few weeks ago. The supply of this SAF was very difficult. So it's one tank coming from somewhere in France. It's not easy today to have SAF on an airport. So today, that's the first point is how we can have an industrialization of this production and so industrialization of the supplying. The second point is the price. But today, so the production is very low, the price is very high. We expect that the price will be lower with a higher production. But today, it's between 3 and 5 times more expensive. So at the beginning, it's only 1%. It will be 5% in 2030. So we'll manage this price like a cost, like all the costs that we could have in an airline. But it will be a rule, so we'll follow this rule like all the competitors. It's true that it could be a distortion competition with other actors, other airlines outside Europa.
So let's hope that the regulation will have to implement the same level of staff for every airline.
We expect so because it's good for the Earth. It is the goal of this regulation. So
let's hope. Florence, you've talked about the retrofit of small or big aircraft, but what are the perspective for the battery for you?
Yes, for step 2 and 3, hybridization and full electric propulsion, it's for this new market in aviation, it's quite difficult to estimate this market. But as the automobile sector, I think it will be similar, and it will be progressive. It will first concern aircraft with a smaller capacity of passenger, like intercity or urban mobility with commuters and eVTOL. And several companies were already working on the drones or air taxi, like volocopters, Lilium. There are a lot in the world. But today, the most important objective in the world is to reduce carbon dioxide. And with, for the first step with Limatech, we will certify our batteries in 2022, and we'll sell it in 2023. And this is a go-to-market. And we will make and sell 30,000 batteries per year in 2028. And for that, we built a big factory with 3 lines of production. And we will be able on this market, it's a thermal engine market for OEM and retrofit. We will be able to save 1 million tons of CO2 in just 5 years of sales.
Oh, that's amazing. Okay, great news. When you're talking, well, just to give huge numbers, it's about 10,000 commuters expected to be on the ground in 2035 and about 15,000 eVTOL. So it will be also lots of work for you on the engine point of view. Do you believe in electrification of the aircraft as a propulsion?
Oh, yeah. Well, not only we believe in it, but we work on it, of course, yes. Well, we've worked on the electrification of the aircraft from non-propulsive functions for the last 20 years already. And so, yeah, we do have some projects with, in particular, our company, Safran Electrical and Power, working on powering powering small aircraft.
No, regional aircraft. Do you believe in 2035 we'll have a 70-seater fully electric?
Well, we believe it will be. We will start with small vehicles. So typically, as Florence said, typically eVTOLs or helicopters or small
commuters.
Yeah, commuters. Yes, that is the first step. Then if we get to larger aircraft, then we have other solutions that we are thinking about, that we are preparing. So there will be a limit, probably an upper limit to the size of that can be powered with electricity.
Great. Emmanuel, what about the young pilots? How do you teach them to be eco-friendly?
As I told you, it's when they arrive in our airline, so we explain them the fuel policies, the best practices, and how you can reduce the fuel consumption, and all these practices are taught during the training, so at the simulator, in flight, and so it is like this in Transavia today. I think that for all the pilots, it is a competence that must be teach and develop in a small school when we start to fly. So and after in the airline. So and today we can see that it is electrification of the aircraft has already started on the small aircraft. So in the school, in the flying school, sorry. And so today, so the pilots start today with a new technology and with the culture of the reduction of the carbon footprint.
Because last year, the first fully electric plane was granted the allowance to fly in Europe, and it's a two-seater, so it's very good for young pilots learning in school, right?
Yes, certainly, because they can discover the new technology, maybe the technology of their future aircraft when we'll start in an airline.
Are you ready for the next generation of aircraft?
Yes, we are ready because we are
expecting.
Yeah, we're expecting. We are pilots, so we like to pilot new aircraft, new technology, and it will be certified, so it will be totally safe.
Thank you. Now, let's introduce the video with Ampere. Ampere, which is an amazing company. Maybe you will give them batteries also, and I come back to us after that.
I'm Benjamin, the Program Director of the Starburst Accelerator. Today, you're going to hear a discussion between my colleague Xavier Tellerman and Kevin Nordker. Kevin is the founder and CEO of Ampere, a startup developing hybrid electric aircrafts, who was part of our very first cohort in 2018. Since then, they've made amazing progress. They've hired a world-class team. They booked a pre-order backlog. They've flown the aircraft extensively, and they've raised an additional round of venture financing. In February, they announced being acquired by Surf Air, a regional aerial mobility service provider, in a deal valuing the company at $100 million. We've been very pleased to work with the founders at a very early stage and continue to support Kevin and his team in making electric aviation a reality. Now, let's hear the update on Ampere's project.
I am the co-founder and CEO of Ampere.
Okay. And when did you start?
When did we start? We founded the company in early 2016.
Okay, so 5 years already.
Yeah, over 5 years now. Yeah, it's been amazing. And actually, I met the Starburst team in 2017. Okay. Was when I first met them, actually. So it was and then I think we formally joined or something structured in 2018. But like, it's been a long time. It's incredible just how. Yeah.
So Kevin, what are the main advantages of a hybrid electric aircraft?
Well, when we think about a hybrid electric aircraft, or really electrified airplanes in general, there are two primary value propositions, benefits that they bring. Number one, we're able to reduce the fuel burn, which directly reduces the direct emissions of those planes. So it's the noise emissions, the greenhouse gas emissions, the pollution emissions. These are things where you can see that immediate benefit from switching over to the hybridized or fully electric propulsion. And then, of course, when you're reducing the cost of fuel, so you're using electricity instead of your combustion fuel, and you're simplifying the systems, your maintenance gets lighter. Now, all of a sudden, you can actually save some money too, and actually improve the economics of the operation. So switching over to hybrid brings those benefits. It's a partial step toward fully electric. But one of the other benefits that hybrid brings above fully electric is that hybrid is able to be really useful immediately. There are only a few circumstances where a fully electric plane is viable. It's generally on the smaller, it's like the 2-seaters or 4-seaters currently that can be flown fully electric. But if you're trying to do a commercial transport class plane, that hybridization really enables you to have meaningful payload, meaningful range, meaningful speed, while still getting some of those electrification benefits. So those are the key for hybridization. Sustainable aviation fuel is one of the many solutions within the ecosystem of sustainable solutions for aviation. So absolutely, when we're architecting our hybrid systems, we want those systems to be able to fly on sustainable aviation fuels as well. We think that hybridization may actually be one of the ways that sustainable aviation fuels can be made affordable, which when just used pure sustainable aviation fuel, it's quite expensive currently, but with hybridization, maybe that balances out and is a better economic value for the operators.
And can you measure the improvement that you had thanks to hybridization?
Well, of course, the improvements are quite simple to measure. So first, we deployed a plane and flew on daily routes out in Hawaii last year. And this plane, an upgrade of a Cessna Skymaster, we call it an electric eel, twin engine, hybrid electric, and we were saving just over 30% of the fuel on average over the course of all of those flights. And so you think 30% fuel saving, now that's pretty significant.
That's huge. And is it thanks to the shape of your plane or thanks to hybridization?
So this is just thanks to the hybridization. The plane itself is an older model that was originally combustion, and we have taken that plane, pulled out one of the combustion engines, and upgraded it to this hybrid electric configuration. And so it is less the aerodynamics, because those stay very similar to the original airplane. And more so, it's just how the propulsion systems operate. And that's why we think that there's a lot of value that can be brought in upgrading existing planes. Of course, that lays a foundation for the clean sheet design planes that we all love and want to bring into the market in the far future.
Okay, so clearly Ampere is leading the way to the hybrid electric planes, and maybe for the more massive planes, the biggest one, how long could it take to make a 100-seater hybrid electric planes?
Well, I think what we're going to see is those larger planes, the 100-seaters and up, become more electric, replacing certain key components with electrified versions of those components. You may even see hybrid electric variants or upgrades to those planes where it's kind of a soft hybrid using a little bit of electricity in certain cases. I think we're going to see hybrids of those planes demonstrated by probably 2030, I think would be very reasonable, maybe even sooner. Now, when would we actually see them in market commercially? I think that might be a little further out. I think we'll first see kind of the 30, 50, 75 type passenger planes in this decade get closer to commercialization. But there's still some pretty significant regulatory technology and ultimately certification, like kind of overall performance challenges that are going to be needed to overcome in order to get those larger planes. So we are working hard to go get our certification. That's a supplemental type certification by the end of 23 or early 2024. So you're looking just a few years down the road when we believe we'll be able to get that approval. Now that is an ambitious but pretty realistic timeline, we believe, to actually getting this upgraded plane into market, into customer hands, and to really be bringing these benefits.
And when was your first flight?
So our first flight was in May of 2019. So a little over 2 years ago. In fact, no, it's just almost 2 years ago to the day. I think it was May 22nd. So yeah, we've been flying for 2 years now.
That's very great. Kevin, thanks you very much for the interview.
My pleasure. Thanks for having me.
Good luck.
We intend to be the first in the country to put passengers on hybrid electric aircraft. And these guys are leading the technology revolution in that sphere. You know, as with all airlines, the cost of fuel is one of our biggest expenses. So as we look for different areas where we can control costs and lower the price for the consumer, cutting the cost of fuel and power is a much greater option for us than trying to control other costs like labor and infrastructure.
That's great. Thank you. Congratulations, Ampere. When we see that, okay, we see that's a new era for aviation. It saves 60% of the operational cost thanks to fuel reduction and thanks to maintenance easier maintenance. Do you think that here in France, in Europe, we get the right amount of support for developing such technologies?
Yeah. So you mean public support? Yeah. Well, public support for this type of, we're talking about new technologies, we're talking about technology risks, we're talking about financial risks as well. And for whether it's for more electrical aircraft or for more, any type of research and technology that we do on the aircraft, aerodynamics, new engines, all sorts of studies, we get support. We get public support. We get support from national support from our states. So here we are in France. We get support from the French government, and we also get support from the European Union. And so why is this support absolutely necessary? It's not just a question of saying we take the money and run. It's because we're talking about those technology and financial risks, which we would not take the regular market mechanics would normally say, well, don't take this risk. So the public support helps this risk because the risk we take it also for future is necessary. It's in political will. So that's the first reason, and the second reason, and it's particularly true in Europe, is that for the efforts have been coordinated. And what Europe has done in the last 30 years is that it has forced us to work together to create networks, technology networks, excellence networks to work. And in particular, that's what the research program called Clean Sky, which is the big European research program we created back in the mid 2000s. This is what it's doing. It's 800 partners participate in Clean Sky. 800 European partners participate. So you need public support to do such. It's really very impressive, but you need the public support, the public also incentives and sometimes obligations. And of course, 2020 was a special year because we had the COVID crisis, which was unprecedented and totally historical. But in France, we got this recovery plan, which is absolutely necessary, not only for research, but in all areas, of course, for our sector. But there is a research support branch of this recovery plan, which is extremely important. And we have committed to work on a future greener aviation. So it's also part of it. Yeah.
Through the CORAC also.
CORAC is the organization that establishes it establishes the directions and the national roadmaps. Yes.
Okay.
The support comes from the Ministry of Transport.
Okay, thank you, Fo. So let's be clear, the golden era of aviation is coming thanks to sustainability, thanks to innovation. So you'll be part of it, and we'll see you in a couple of years just to see how far we've gone. Thank you, everybody. Thanks you for following us. Thank you, Valérie from Safran, Emmanuel from Transavia, Florence from Limatech. Tonight, don't forget, we have at 5 p.m. French time, Paris time, a round table about space. It will be amazing also. Thank you, everybody. Merci à vous.
Thank you.
Thank you.
Merci.
Merci.
Au revoir.
Au revoir.